What's up, guys? Pink Panther here. So let's talk about this Pentest challenge. If you had a chance to look at it, then you know you've got a web server, then behind that a router, and behind that you've got an internal server. And the goal of this challenge is to get root on the internal server. Well, I'm going to show you how to do this, and the way that I'm going to do it is I'm going to use the web server as an entry point into the network. And to do that, I'm going to exploit an SQL vulnerability in the web server's login form. So now let's talk about this login form. When the user submits their username, it gets stored in a PHP variable named user, and that information gets sent to the MySQL server via the MySQL query function. Now, if the MySQL query function finds a match in the database, then it returns a resource, and that resource gets stored into the login variable. Now, further down here, the login variable is used in a logic statement. If the login variable contains a resource, then we're going to get access. If it doesn't contain a resource, then it's going to be false and we're not going to get access. So basically, login has to contain a resource, and that means that MySQL query has to return a resource to it for us to have access. So let's talk about how we're going to get MySQL query to return us a resource. We got two examples here, and on the top one we can see the user has input a bad username. It's not in the database, and therefore you get no returned resources. Now in the second example, the user has entered a little bit more advanced username, I guess you should say, and look what it returns. So what we need to do is we need to get our user variable to contain something along the lines of this on the bottom. Enough studying, right? Let's get on this. Single quote or 1 equals 1 little hash and log in. And there we are, level 2. Got a code and we've got some directions. Level 2 directions, find and read passwords.jpg. And the only way it looks like we can go through this is through the LAN diagnostics. We've got a nice little ping box here. See if it works. And it works. Okay, so what's really going on here is the web page is using a PHP function called shellexec to execute this ping command. Now, the address for the ping command comes from user input, and that input is stored in the variable named option. None of this input is sanitized, and that is why we are able to enter anything we want to, and as long as it's valid, it gets executed. So what we can do is something like this. Instead of just the ping, we're going to get ping plus the ls. Except for we're not going to get the ping because we didn't enter an address, so we're just going to get the ls. See if it works. And there we go. Now let's try something a little bit better. How about ls in? Okay. Now look what we got here. We got a bunch of files, but we've also got a directory, the config directory. So let's have a look in there. And cd config. Okay, so that went through good, but let's check something out. Do an and ls again. Alright, So what's the deal, you might be wondering? Well, when we did the CD into config, it successfully went in there, but it didn't stay in there. So what we have to do is and cd config, and then we're going to double and do a ls. And now we see what's actually in the config directory. And the reason that we used the double and there is so that we could get the ls at the same time as the cd config. That's the only way you can really do this. So we know that passwords.jpg is right there in the config directory. Now we need to read that, because that's what the directions say, find and read passwords.jpg. So let's try again. And cd config and so we're now working in the config directory. We need something that's going to let us read passwords.jpg. So we'll try cat passwords.jpg. Illegal input. Alright, any of you Linux gurus out there know something else? How about and cd config head passwords.jpg. And now we see what's inside. Got a username of admin. We have no password. We have a password hint. 1 and 1 is 0, but 1 and 0 is 1. And we've got a level 3 code now. And we also have a new proceed button that wasn't there earlier. So before we proceed, we probably need to figure out this password hint. Now this one's kind of easy, depending on if you're good with riddles, I guess. Techno riddle kind of deal. 1 and 1 is 0, but 0 and 1, but 1 and 0 is 1. That's an XOR function. If you don't know what that is, look it up. It might be useful. So, XOR is what I'm thinking this password's going to be. Username admin, password XOR, because this is an XOR function. So let's hit proceed, see where it takes us. And now we're in. We got us a shell admin at Kali. Level 4 code. So we're ready to go. So now that you got a shell on the web server, the next logical thing to do would be try to establish connectivity with the internal server. And since you have a network map on the front page of this website, you already know the IP address. So let's try pinging it. Ping 192.168.3.6. And look at this, operation not permitted. There's a reason it's not permitted, and that's because the web server has an egress policy in IP tables. It doesn't let ICMP packets flow through the default gateway, only over the internal network. Well, since we specified an internal IP address, it shouldn't be going over the default gateway, should it? For you network guys, you're like, yeah, it shouldn't be. So let's take a look at this. Going into SBin, looking for the route. Looks like I didn't get a dash in there. Okay, I should probably explain this. Route-in. I typed that, but it didn't show up. And the reason is something about shell in the box. It doesn't let you use the dash. It's got to be the minus sign from your number pad section of your keyboard, whatever you call that thing. So you got two dashes on your keyboard, only one of them works. So we're going to go route dash in to see the routing table and figure out why that ping command tried to send ICMP out the default gateway when we specified an internal address. Now, if you're looking at this route table, there is no static route pointing to the 192.168.3 network. So therefore, if there's no static route, this thing is going to send it all out the default gateway. We can't have that because that's not where our internal server is. So the network guys are thinking, okay, let's add a static route. And you're right, that's what we're going to do. sbin route add 192.168.3.6 gateway 192.168.2.100 etho. Okay, looks like it took the command fine. Let's check the route table again. sbin route dash in. You gotta use that special dash on this fucking shell. Everything else about it works great though. I can't complain about it. Just that one little thing, some characters. So anyway, let's check out the new route table and see if our route was actually added. And there you can see it at the bottom. 192.168.3.6, any packet destined for that IP address goes out the gateway of 192.168.2.100. If you're looking at your network map, 2.100 is the interface of the router closest to the web server. Has to go through that interface to get through the router to the internal 192.168.3.6. So now that we've set up our route, we can try pinging again. Ping 192.168.3.6. Okay, now it's different here. It's not saying operation not permitted. It's saying destination host unreachable. So we've gotten past the IP tables. Everything's going to where it should. It's just not finding anything there. So why not? Well, let's check and see if the router can ping 192.168.3.6. So to do that, we're going to have to log in to the router. Now hopefully we can just SSH into there. I think most people will think about that. I hope they will. At least any decent hacker will try it. SSH 192.168.2.100. And there you go. You have a level 5 code. And if the person who is doing this challenge, if they look right here at the top, they'll see some really important information. This router, the banner, happens to display the status of the interfaces. We can see that LAN 1, the status is active. 2.100. LAN number 2 interface, it's not active. And that is on the 192.168.3.100 side. Okay, that's probably going to be an easy fix. We just have to tell the router to bring up the interface. So we'll enter 2 because we have two options here, 0 log out, 2 or shell. We want a shell on the router, so we got 2. And you'll see we end up with some kind of crazy ass, I don't even know what is the deal there. But anyway, ifconfig should work. We're looking for LAN 2, 192.168.3.100. That interface is down. We need to bring it up. Damn it, Tor. Come on, boy. Okay, right here. 192.168.3.100. That's our problem interface. All these other interfaces up here, they're active. This is active. But LE1 is not active. And LE1 is the name of the interface we need to bring up. So, to do that, ifconfig LE1 up. And it looks like it worked. We gotta get out of this shell somehow, so we're gonna type exit. And there you have it. Right here. LAN 2, status active, 192.168.3.100. Now the router is fully functional, and we can get out of this SSH deal and go back to our web server. How do we log out? Got a 0 right here. It's the choice to log out. Alright, now we're back to our shell on the web server as user admin. Now let's try that ping one more time. We got the static route on the web server set up to go to the local interface on the router. Then we logged into the router and brought up the distant interface that goes to the internal server. So we'll try ping 192.168.3.6. Look at that. It's beautiful. Ping is working. We've got connectivity. All we have to do now that we have connectivity is try to figure out how do we get a shell on the internal server. Well, how about we do some nmap? Oh, that's nice. See all these ports open. Now, the reason all those ports are open, people, is because I fucked up. That's right. I forgot to turn on the firewall. So let me go do that right quick and get this fixed. Okay, so we see here the host seems down. That means our firewall's working over there on the Metasploitable machine. So we need to alter our command. So we got -pn. We're not going to try ping. We're just going to do the ST. We're going to do the TCP scan with no ping on the 192.168.3.6 address. Hopefully this time we'll get something up. We got one port 22 SSH. So what we're going to do here is we're going to use Hydra to brute force the SSH login. Now we're going to use the login name of root because root is on just about every Linux-based device. We don't know a password. We're going to use the password list located on the web server in the directory user share dirb word lists, and we're going to use the common.txt word list. And get the timing set at 8. SSH is what we're going to be brute forcing. I'll execute that and see how it goes. Alright, there we have it. Login is root and the password is admin tour. So now that we have the username and password, we can just SSH straight from the web server across the router and into the internal server. SSH root at 192.168.3.6, and it should ask us for a password, which is admin tour. Anyway, alright. And there we go. Root at Metasploitable. And that's the end of the challenge. Anyway, see y'all later.